Now we're going to start Chapter 6, which is an introduction to chemical reactions. So first, how do we tell if a chemical reaction occurs? Now typically you're going to see some sort of visual signs, but sometimes you're also not going to see something visible. And we will go over these next. So here are the things to look for that show that a chemical reaction occurs. For instance, we're going to see a color change. Maybe we pour two liquids together in a solid or a precipitate forms, or such as, say, baking soda and vinegar. We're going to see some bubbles, some carbon dioxide. And finally, maybe some heat is produced or heat is absorbed. So either the reaction is going to get warmer or it is going to get colder. So here, what is a clue that a chemical reaction has occurred? So a battery is dropped into some water and we see some bubbles. So when we see bubbles, we know that a chemical reaction has occurred. Now here, some colorless hydrochloric acid is added to a red solution of cobalt-2 nitrate. So here's the initial red solution, added some hydrochloric, and then we get to this blue. So here we see that the color change indicates a chemical reaction has occurred. Now finally, we have two clear solutions. The first solution up here is a clear yellow, and then the second is a clear no color present. When we mix the two, we're going to get a nice bright yellow solid. So a solid forming is another indication of a chemical reaction. So now we're going to take that chemical reaction that we can visually see, and then from last chapter when we learned how to write the names of these chemicals, we're going to write what's called a chemical equation. On the left side of our equation are what's called the reactants, and on the right side are our products. So in this example, when we combine methane and oxygen, we're going to get carbon dioxide and water. This is your typical combustion reaction. It's going to be with oxygen, and you're always going to form carbon dioxide and water. The reactants are on the left side of our arrow, and the products are on the right side. One of Dalton's theories is that our atoms cannot be created or destroyed, and this is what we use to help write our reactions. That same carbon atom that is on the left side of the arrow in the reactants is the same carbon atom that's in that carbon dioxide in the products. So the total number of atoms should never change in a reaction, because we cannot destroy an atom and we cannot create one. So in order to maintain our cannot destroy and cannot create atoms, we have to do what's called balancing a chemical equation. So we look back to our methane and oxygen forming carbon dioxide and water. Well, first off, we have one carbon on the left and one carbon on the right. That's good. But now if we look at our hydrogen, we have 4 hydrogen on the left and only 2 on the right. So we lost 2 hydrogen atoms, which we know cannot happen because we cannot create or destroy. So we're going to do what's called balancing. We're going to check our hydrogens. Here's 4. And now we added 2 water molecules, so it gave us a total of 4 hydrogen. So now what we're able to do is balance the equation by writing coefficients. And our coefficients are these numbers right here that come before our formula. So that tells us we have 2 oxygen molecules and 2 water molecules in our equation. Whenever we write an equation, we always need to indicate the state. As a solid, the molecules and the atoms inside a solid behave differently than the atoms and molecules inside liquids and gases. So we need to indicate that with a subscript, and then in parentheses our letter. S for solid, L for liquid, G for gas, and AQ, which means aqueous or dissolved in water. So typically you're going to find our ions, such as sodium, chloride, nitrates, acetates, dissolved in water. And you're going to have a little AQ after them. So right here is an example of putting some metal into water. We have potassium going into water, and we form hydrogen gas and potassium hydroxide. So we have solid potassium indicated by our S in parentheses liquid water forming our gas, and aqueous because that potassium hydroxide is dissolved in that water. So here, when blue light shines on a mixture of hydrogen and chlorine gas, the elements react to form gaseous hydrochloric acid. What is the unbalanced equation? Now this is tricky because remember that hydrogen always occurs as a diatomic molecule. It's a diatomic molecule. So that means like right here it's H2 or H2. And then we want to form HCl gas. So notice our G's here is a gas. So right away we can cross out B because we're not forming hydrochloric acid gas, we're forming here hydrogen and chlorine. So that cannot be correct. So D is the correct answer because we have hydrogen is diatomic plus our chlorine gas forms HCl. But notice this is unbalanced. They wanted the unbalanced equation. So our balancing equation goes all the way back to the idea that our atoms cannot be destroyed and our atoms cannot be created. So we're going to follow this all the way, and this always happens in all chemical reactions. The same number of carbon atoms on the left is going to equal the number of carbon atoms on the right. Now when chemists do a reaction though, they want to determine what are the products formed. And the way they do this is by using those physical properties. Because water is always going to boil at sea level at 100 degrees Celsius and freeze at 0. So even though two colorless liquids, say ethanol and water, they both look the same, but upon further inspection, say their boiling point, freezing point, melting point, those are all going to be different. And those formulas are unique to every compound. So you never change a formula to balance the equation. You always use the coefficients. So these are the general steps onto how to balance an equation. First, read the description. What are the reactants, what are their products, and what are the states? So we say hydrogen gas, we know that's diatomic, so it's H2, we need a subscript G because it's a gas. Same thing with oxygen, and if it forms liquid water, water we know is H2O, and liquid we know a subscript L. So now we write the unbalanced equation, using our subscripts, given our name, and also the states of matter. Next, we look at the equation with the most complicated molecule. So here we have H2 plus O2 yields water. Now water is the most complicated because it has two different atoms. It has our hydrogen and our oxygen. So we want to look at that and count the atoms and then start by looking at the water. So looking at the water, we noticed that originally we only had one oxygen. Well, in O2 there's two oxygens. So now we're going to have two molecules of water, so we balance our oxygen. So now we have two oxygen and two oxygen. But because we changed our water, we now changed our hydrogen count. So we need to go back and figure out how do we change our hydrogen so that it matches. And we notice that we can have two molecules of hydrogen gas, H2, to equal our 4 hydrogen atoms, and we have 4 hydrogen atoms on the reactants. Now just like in math, there can be more than one answer, such as 1/2 equals 2/4. But we want to write this in the lowest coefficient. So here we have 2 hydrogen plus 1 oxygen yields 2 water. It's the same thing as saying 4 hydrogen, 2 oxygen yields 4 water, but we want it in the lowest coefficients possible. So we divide each of those by 2 and we get 2, 1, and 2 as our coefficients. So here we want to find our lowest coefficients, the lowest number, and determine the sum of those. So we count our number of ions and count our oxygens. Well, we notice we only have 1 ion on the left and 2 on the right. So now we need to have 2 FeOs. But because we did that, now we changed our oxygen count. So if we look again, now we have 4 oxygen on the left and 3 on the right. Well, that's not good. So what we need to do now is figure out how can we get those to match each other. So what we can do is multiply the Fe2O3 by 2, but now we changed our irons. So let's go back and fix our iron. Now we have 4 iron and 4 iron. And now we have 4, 5, 6 oxygen and 6 oxygen. So the correct answer is 7. We have 4 plus 1 plus 2 yields 7.